Again, we're going to use the same technique to create a unique ID and a primary key for our table. Now you could do all of this with alter commands and take the existing table and alter it to have these things. But generally speaking, these are things that would have been done if we'd built a table that was properly built in the first place. So we're going to rename the table and copy the data back in again. So we're going to do the same process, alter the name to a different name. We're going to create the table. Notice that we still have the check constraint in there. Okay. But we're going to add this additional ID, which is namelist ID. And I'm going to add it as a universal ID, not null, which means you can't have it empty. And I'm going to create a default for it. You can have defaults for every column. And the default is going to be this uuid generate v4, which is going to populate the field with an ID if we don't supply one from outside. And I'm going to say that it's a primary key, which means it's going to create an index and it's going to be unique. And this is going to be the key that when nothing else happens with the table, like you select everything out of the table, this is the key that it uses. So to be able to use this uuid generate v4, I have to have this package in Postgres, create this extension with this function in it to create these universal IDs. Now, most of the time, people create sequence numbers. The problem with sequence numbers is they have to come from the database. And that turns out to be a big problem. It's much easier in a lot of cases to use a uuid, which doesn't have to come from the database and can still be unique. This means you can generate it wherever you're generating your data, and we're actually going to take advantage of that for generating some data in another homework exercise. So the uuid makes a much more convenient key. Convenience comes at a price. These keys are bigger than a sequence number, but it also has advantages. For instance, B-tree indexes have to re-level if you count up the values. So you have a sequence that generates 1, 2, 3, 4, and you're trying to put it into a balanced tree, and you get a very unbalanced tree because every new value is bigger than the last one. Then the database has to go in and do an expensive rebalance operation. So being able to add a key in this fashion where they're going to be uniformly distributed is a lot of advantages to it. So again, we'll take the data that we saved in the temporary table, we'll copy it back to the original, we'll verify we got the right number, and we'll get rid of the temporary table. All right. Now, when we get done, if we do a select from it, it should look something like this. Now, you will get different IDs for each row, but you should have this set of data over here. And notice that we have a duplicate in here. Okay, Jane True appears twice. And when we do this with these unique IDs, there's Jane True appearing twice, we'll be able to identify that particular Jane True so that we can eliminate the duplicate permanently. Okay, I've put together all of the pieces, the alter, the create table, the insert, and the two selects together all at once. We've run it, and we can look at the results. The alter worked, the create table created the new table with the primary key. And then we did the insert. You'll notice when we did the insert, we got back 11 rows that we inserted, which is good. And when we do counts from both of them, we have all 11 rows. So at this point, we should be able to go and just get rid of the temporary table. And we now have a table with a primary key. So let's get rid of that. And that worked. And now let's do a select from it and see what we get. We'll do it on both here and in PSQL. And yes, I have data and it has unique IDs. And if you compare the ID here to the one that I gave you in the example up here, you'll find that it's different because every time it generates one of these, it's a unique ID. And you can do this anywhere in your stack. You could generate IDs in a front end and then send that data delayed to a back end. Which is really useful to be able to asynchronously generate unique IDs for inserts. It makes for a really nice way of dealing with IDs with the cost that you'll notice that these IDs are long and people are not going to want to ever type in those IDs. This is not like a W number here at the university that is relatively short and you can actually type it and remember it. These things are big. That's how they get to be unique. All right. Let's move on to the next thing, but now we have a table that actually looks to me to be a decent table, as in it has some data, it has unique IDs, it has a primary key, which means we can clean up the data and remove the duplicates.